Hello everyone, welcome to a new lecture. In this video we are going to talk about fossils. So what is a fossil? Well, fossils are remains of past life. So you have seen fossils, I bet, in museums or in pictures or on the internet. Fossils are remains of past life. You have seen big dinosaurs, their skeleton. This is a fossil because these animals that have lived in the past, their parts, so for example, their skeleton, their teeth were preserved, and then now we can look at them. These are called fossils. The science that deals with the fossils or the remains of past life is called paleontology, and the person who studies fossils is a paleontologist. So fossils are remains of past life. We have several types of fossils, or we have several ways that we can get fossils. And these ways are permineralization, molds and casts, carbonization and impressions, amber, and trace fossils. Through all these ways, we can get fossils. So let's look at each of these in more detail. The first one, permineralization, is when mineral-rich groundwater permeates porous tissue. So bones and wood and a lot of other organisms, they contain porous tissue. And when mineral-rich water submerges and interacts with these kind of porous tissue, it will fill them and it will turn them into rocks. So for example, here we have an example of petrified wood. Precisely, petrify means something that have been turned from wood into stone. When ground-rich water interacted with this piece of wood, it turned the porous tissue of this wood into rock. And in this example, and in generally, wood is turned into chert. This is another example of a skeleton that had interacted with mineral-rich water, and it turned and preserved the skeleton of this animal through permineralization. So permineralization is when mineral-rich groundwater permeates porous tissue. Second, we have molds and casts. Molds is when a shell or other structure is buried in sediment and then dissolved by underground water. But if the space is subsequently filled with mineral, then a cast is formed. So when we have a shell and then this shell is buried in sediment and then dissolved, we get something that is called mold. When the space of that shell is filled with mineral, it creates a cast. So just like here, we had a shell, it was buried in sediment, probably the shell was dissolved, and then the space of that shell was filled with mineral, it created a cast. And molds and casts are another type of fossils. Then we have carbonization and impressions. Carbonization is a thin residue of carbon formed by pressure squeezing out internal components of an organism. So an organism, most of the time it's a leaf. When this leaf gets buried and through pressure, the internal structure of this leaf, like gas and liquids, gets out, a thin residue of carbon will be left out, and that is called carbonization, is a type of fossil. So just like you see it in this picture, it's a flat imprint or a tattoo of the organism. As a result of pressure, all the internal component of liquid and gases came out, and the flat print of that organism was printed on the bed. On the other hand, impressions is something else. I bet you have seen in Tom and Jerry cartoons when Tom chases Jerry and suddenly Tom hits the wall and the impression of his face get printed into the wall. That is impression. So just like that, impressions, when you have a leaf or another organism and they get buried and the layout and impression of that organism gets printed into the bed, but you don't have any leftover of that organism, that is an impression. So carbonization is a thin residue of that organism being printed on the bed, but impression is just the impression of the organism. Next, we have amber. Amber is a type of fossil in which some insects have been preserved in the hardened resin of ancient tree. Since insects are very delicate and as soon as they die, they will be decomposed, they have to be preserved in something that will prevent decomposition. And something perfect for that will be resins of ancient tree. So for example, as you can see it in this picture, we have an insect millions of years in age. It died and it was preserved in resins of ancient tree. So amber is another type of fossils. Lastly, we have trace fossils. We have several types of trace fossils. We have tracks, we have burrows, we have coprolites, and we have gastroliths. These are all types of trace fossils. Tracks are tracks of animals that have walked on sediment, and then these footprints were preserved. Sometimes they are not footprints, sometimes they are prints of body being dragged on sediments. So tracks are traces of animal walking on sediment, and then these traces were preserved. Burrows are interconnected tunnels that have been created by small animals that live in sediment, as like you see it in this picture. They are interconnected tunnels. When they get preserved, they create fossils like that. They're very, very beautiful. They look like veins. Coprolites are stomach matter or rock that have entered stomach of an animal. They have been digested and then they have been thrown out. Gastrolith, on the other hand, are stones that have been used in digestion. So big animals like dinosaurs, so when they ate their prey, rocks also were picked up and they were eaten. Because rocks in the stomach helps digestion, it grinds the food and it creates fossils that are called gastroliths. Gastroliths are very, very shiny and they have round edges just like that, and geologists love to find gastroliths. I remember my friends running around the field looking for gastroliths, and when they found one, that was the best day in their life. So trace fossils, we have tracks, we have burrows, we have coproliths, and we have gastroliths. Okay, so we have talked about fossils, we have talked about how animals have been preserved millions of years ago and now we can look at them. But what conditions favor preservation? Well, two conditions favor preservation, and they are rapid burial and position of hard parts. Since organisms contain tissue that can be decomposed easily, so as soon as an animal dies, all the soft tissue will get decomposed. Not a lot of that animal will be preserved. But if they get buried rapidly and if they contain hard parts, then they will be preserved and they will turn into fossils. So for example, something like an octopus, since all body of octopus is tissue, it does not contain any hard parts, an octopus will be very, very hard to turn into fossil. But something like a dinosaur, since the skeleton of the dinosaur is a hard part, it will get preserved after it will be buried. So rapid burial and position of hard parts are conditions favoring preservation. Now moving into a concept, and that is correlation of rock layers, which is about how we can use fossils or the bits that contain fossils into geological dating, or in better words, into relative dating. And that is because we want to develop a geological timescale that is applicable to the entire Earth. It's not local, but something global. And in order to do that, rocks of similar age in different regions must be mashed up, and they get mashed up through correlation of rock layers. So what is correlation of rock layers? Each rock layer contains fossils unlike the previous or after, and sedimentary strata in widely separated areas could be identified and correlated by their distinctive fossil content. Since each rock layer contains fossils that are unlike the previous or after, so if you have two stratas in two different geographical locations but they contain the same fossil, you basically correlate these two stratas and you say that they were deposited at the same time, because each rock layer contains fossils unlike the previous or after. Therefore, these two stratas, even though they are from two geographically different areas, they have to be mashed up or they have to be correlated. This is a way we can use fossils in geological dating. We can basically correlate layers. Then we have another concept, and that is the concept of principle of funnel succession. Principle of funnel succession basically says that fossils succeed one another in a definite and determinable order, and therefore any time period can be recognizable by its fossil content. So what basically this principle says that each period contains certain fossils that are distinct to that period. So for example, you cannot have a human bone in a period where mammoth or dinosaurs lived, since humans came after dinosaurs. And apply this funnel succession to every fossil that you have. Fossils come after each other, and certain fossils cannot be found in a period before they existed. Then we have something that is index fossils and fossil assemblages. Index fossils are those that used to define a geological period. So for example, all these are fossils and they each represent a geological period. So for example, here, Jurassic period, you have this kind of funny name fossil. Here we have Cretaceous period, you have Scaphites, Hippocrepes. It's a creepy fossil. So index fossils are those that used to define a geological period. Then we have fossil assemblages. Fossil assemblages are a group of fossils used to establish the age of a bit. These fossils or fossil assemblages come in a group. They exist together and they are used to establish age of a bit. So we have index fossils and fossil assemblages. And with this concept, we come to the end of our lecture. So to recap,